So I think Manish and Rachit are joining us for the first time. Is that right? Manish Singh and Rachit Garg. I don't think so. I've interacted with you earlier. So we are recording this call. We'll share the video also. I'll just wait for another few minutes. Maybe it's just 4 minutes past 6. Maybe for another 4 5 minutes, and then I'll start off. Yeah, Rachit, thanks for joining. So Rachit and Manish, because I've not interacted with you earlier, do you have any experience with, say, OpenCV or any of the imaging libraries? Okay, not an issue in case. Uh, okay, I'll start giving you some background on what we are doing and what this is about. So, GIS, or geographic information or location information, has become quite uh, let's say relevant. I won't say relevant, it was relevant earlier also, but it has become easy to gather and easy to share and easy to process. So just like business intelligence, a lot of people nowadays are talking about location intelligence. Earlier it was mostly about I hope you can see my screen. Okay, so earlier it was more about earlier it was more about business intelligence or things like that people were talking about, and using machine learning and Python and various let's call it new tech. But recently in India, and maybe for about, say, quite a while now, maybe about 20 25 years or so, globally, location intelligence has become very very important. Now, what exactly does location intelligence do, and how can we kind of build upon that? It's got to do with understanding where you know where a certain thing is located, whether it's a non-living entity, like maybe some kind of ship or something which is there, or a vehicle which is some transportation is happening, or a living entity. So even knowing as to where a person is sitting, in which restaurant or which city, there are a lot of people who are there who are accessing, say, Twitter or things like that. So there's a lot of projects which are happening, and there's a lot of information which is being gathered. How this information is utilized is again a very complex map. Yeah, AK, it must be something on your side, the network. Can you hear me now? Aman, you just posted something on WhatsApp. Can you put it in the chat? Whatever that is, I won't be able to access the WhatsApp. Just put it in the chat. Okay. So there will be a lot of different uses for this kind of information, that is location intelligence. Now, how does location intelligence how does it get gathered? So gathering location intelligence is more of a remote sensing task. So either it's a remote sensing task, or whatever device that a person is carrying, whether it's a mobile, or there is any kind of Okay, so this is some official Google. Okay, yeah.
Yeah, this is the SDK of Google AI.
So it's linked with some kind of map or something, or is it?
This is the code I saw. It's also linked, I think, the migrating form.
Okay, okay, wonderful, wonderful. This is good. So, is it? I think it is 3D graphics, AR core, Android. Okay, so this is basically a AR this thing, which is okay. So that is great. So AR is on not only with the Android but also with the iOS and other things. It's quite AR implementation is the easy part. That is not so difficult. So okay, so how to get location data? So location data will come to you from two three sources. So there could be some IoT device, there could be some mobile phone somebody is carrying with the GPS, or maybe there could be some something like Twitter, the API which is tracking somebody's mobile phone, and then through GPS that data is coming to you. So getting location data is the first thing. So that's the first challenge. So it's common to all our tasks mostly, whether it is machine learning, whether it is deep learning, whether it is any of these data intensive tasks that we are doing. For all of them, the most important thing is, of course, getting the data. So once you have the data, then things are much more simpler. uh, so what do we want to do? We want to end up understanding this location intelligence market, and how does this basically work. So whether it's from the point of view of a global scenario, or from say maybe India scenario, or whatever it is. So how does this work? And once you have the location intelligence, what processing will you do with that data? And once you have done some processing, what is the output? So simple. The input would be location data. So you'll end up doing some processing. There will be some output. Whether that output is given as some kind of map, or some kind of a very simple this thing, maybe again some location this thing, or you want to give it out as a augmented reality app or a virtual reality app or whatever. So those things will come later on. The first point is to understand how data can be gathered. Now if I ask you, all the people who are on the call, um, and just put it in the chat as an answer, if you want to understand that in Gujarat, in Ahmedabad, or say maybe in Bengal, in Calcutta, uh, you want to understand a particular area. You want to maybe understand a particular region and see how many people are there, what kind of buildings are there, or whatever is there. So in today's date, in with today's scenario, what will you do? How will you understand that? Just as an example. So what is the first thing that comes to your mind? So basically, you want location intelligence about some city in India. How will you do that without moving from your own place, and without going there? What is it that you will do? Yeah, so Aman is right. Maps, but what kind of maps? What maps do you have access to? Could you please 1 second? Let me. I need to see the chat. So Rachit says crowd sensing like Google does with maps. Rachit, can you explain yourself? What exactly is crowd sensing? Sorry, I'm not aware. So AK is right. Okay, Google Maps. Aman is also right. Google Maps. I'm sure Rachit also is correct, but I don't understand what exactly crowd sensing means. So, Rachit, it's okay. You can even speak with us, so that's okay. You don't have to put it in the chat only. Okay, using phone sensor and gathering location data. Yeah, so maybe that Google does, right? But we can't do that. So obviously, we can't be accessing people's phone, and let's say we as a group, some of us who are doing this project, we want that data. So how will we get that? We can't be accessing people's phones. We are not Google. I don't know if Google does that legally. I don't know. I never saw on my phone anything telling me that I will you share location with Google. I have not shared it. So maybe there is something built inside the Android. I have a very basic Android phone. So maybe there is something built inside it which Google is using. I don't know. Rachit, do you know more about this? Anything else you can let us know? So, okay, so obviously, we can't have access to that data. So, unfortunately, that doesn't work out for us. So, let's say, as a small team who wants location intelligence, what are the options with us? So, one option is that what comes to my mind is that use some kind of API from Google. So, Google used to have these free APIs which used to, give you access till at least I think around 3-4 years back. But now those APIs are all paid, so there is no way to get a free this thing access to data. So if you don't have free access to data, then what basically will happen is that whatever product that you end up creating, you will have to pass to the customer the cost of that data that you are accessing through some API. So then that product, to make it scalable initially will become a problem. Then later on, maybe okay, so maybe you built in that cost into that product's cost and you do that. But let's say we want some kind of free access to data. So what do we do? What can we do? Any thoughts? Any ideas? Vakar, any thoughts? Okay, so what basically so that is the main struggle. So how do you get free data or location data? So probably OpenStreetMaps is the only option. So that is what I could see. OpenStreetMaps is the only option. Besides that, maybe there are other options which I am not aware. So we will probably have to see that later on. Okay, I'll go back to the PPT now. So that was the first basic question. So understanding the market, to even understand the location intelligence market or the GIS market or whatever, and see what is happening in that. Firstly, you need data. So how do you get that data? The Google data is not free. So these are our focus areas. So basically, okay, we want to do remote sensing. Uh, why we want to do remote sensing is because, like me and Aman, we've had a couple of discussions on this. And yes, there is another option which is there, that you give a some kind of app to a user who's using his mobile phone, and that person will kind of go and give you that location information and through some manner. So there is a lot of things which can be done. So through one of those processes, that person will give you voluntarily that information. There are challenges with that. Firstly, a human being is involved. What we want to do is, we don't want human involvement in this. We totally want to automate it to as much extent as possible. That is the first thing. The second thing is that maybe in urban areas, or maybe with areas with population, you can do that. But otherwise it is difficult. So maybe some area which is really remote and you want some information from that area. So that's the reason it's called remote sensing. You can't necessarily involve people. You can't be depending on somebody to be on that location and then giving you that information. So that is one. So just below remote sensing, you see Google Maps written on the slide, and Google Maps is not necessarily highlighted, or it's not in that, it's slightly in a gray font. So Google Maps is it's been tried. It's already a paid service. So that's not an option. That's the reason I've kind of abandoned that thought. The next one is OpenStreetMaps. So OpenStreetMaps, of course, can be one of the options, and I'll talk about it later in the this thing. The next is lidar data. So lidar data, if it is possible, then that is the best kind of location intelligence data which is available in today's date. So lidar is not a very old technology, and it is one of the most preferred in today's date. So that is one thing. Second, what do we want to do? We want to map urban areas. So urban areas, basically the street maps or the buildings and other things. That is what we are interested in as a first level task. uh, then you can end up doing a lot of things for the government, and maybe for the uh, defense ministry and things like that, but all that comes on later on. So if you have a working prototype, you can go and approach them, and then your issues with data and other things will get solved, because obviously then they can support you on all of these things. But nobody will bother till you don't have a prototype, a working prototype. For a working prototype, you obviously need a lot of data to process, and freely available data. So okay, anybody has any questions till now? Any thoughts you want to share with me? Anything you are able to make out what I'm saying? Ayush, you can hear me? Hello, Ayush. Yeah, okay. So this is basically then comes the private retail user, and that's the reason what that's what I started off my discussion with Aman, and that's the reason Aman actually suggested. So he's on the right track when he suggested that. He was not aware that we are trying to do many other things. So he's given an absolutely good suggestion, and I've already thanked Aman for that. So that's an excellent suggestion, to maybe have a person on site and give us that information. So that is one of the use cases, one of the very small use cases, so to say, of what we are trying to do. Okay, and this is now basically a quick introduction to the existing GIS landscape. So remote sensing or GIS and such things. So anybody, any guess how much how big a industry this is, or how big a market this is, wherein people are trying to get something done. So we'll just look at that. So who are the global players? So there is of course this organization, which is the open source organization called the QGIS. So that's an open source GIS. So that link is there. I'll share this PPT later on. You can have a look. Then there is ArcGIS. So ArcGIS is basically the leader in GIS, but again it's a paid system, and it does not help you gather location intelligence. Neither does QGIS. So for both of these, you need to provide your own data. They will not provide you the data. So data has to come from somewhere, from the organization which is using these products. So one product is open source, the other is not. Then there is this organization called ESRI. So ESRI, ESRI, like it's usually called, is one of the leaders in this domain, and they also churn their own data. So they have a lot of data of their own. Similarly, Pitney Bowes is there, and then comes this organization called Mapbox. So here, what Aman had suggested, so these guys are doing something similar. So they are looking at augmented reality plus some kind of geo mapping and things like that. And then there is Planet Labs. So Planet Labs is quite famous for providing that Kaggle competition, where people had to search for ships. So within satellite images, uh, we had to basically search for ships. So that was a Kaggle competition. That's the reason Planet Labs is mentioned over here. So within India, what is the scenario? So within India, of course, there's a lot of advancement. I have not put everything here, so there's a lot of other things which should be coming on this slide. I actually didn't have much time to do that. First thing, the Indian Society of Geomatics, then Indian Society of Remote Sensing, then there is Indian National Cartographic Association. We have a lot of our own satellites which provide map and satellite maps. So in India, if the government or any organization who's doing this at a very large commercial scale, you don't necessarily have to depend on the Google Map data or the this thing. We have our own satellites, and if in India you are accessing the OpenStreetMap, you also get to see our own satellites view of things. So that is there. And this is again, this is an international organization called Harvesting. So this is how they've kind of moved right from early say 2016 till date. What you can't see over here is basically the ideation part of it, and then from 1 second, this is I think 2016 only. Yeah. So and in 2018 they've done their India subsidiary setup and all that. So if you go through their site and you try and understand what they are doing, so they are also doing a lot of location intelligence work, especially in the farm sector, in the farming sector. And if I'm not wrong, they are also involved with our government, but that part I think I'll have to check again. But this PPT was made some time back, so I don't remember. Okay. So the global remote sensing market is basically $200 billion. And that's how big the market is, and that's the kind of opportunities which are there. And on my system, the slide is changing, but I can't see the slide change on the Google Meet. I don't know why this is happening. Yeah, so there is a delay. Okay, so this is the 200 billion USD market basically, and that is the kind of scope that is there for anybody who's working in this market. Now, let's say we were to create something which had augmented reality, and we had also some kind of data available with us. And how would we do that? So the first thing that comes to mind is okay, like Aman has shared right now. So there is the Google AR this thing. So yes, I've not seen the Google AR, so I'm not aware what exactly it is. So it is probably that Android this thing. But to create a AR app or to create an augmented reality app, I don't think so. This Google AR will help. So you will have to use some other this thing. So Unity is one of the preferred ones. So Unity is owned by Microsoft, so it's a proprietary product of theirs, and that is the one which is quite easy to use and very very user friendly. Doesn't require much, very very basic knowledge of C sharp. That's all. Most of the things can be done using their GUI. And I've given reference of one person here. So his videos are very famous about this augmented reality and Unity and all this. So what he's basically done is he's using the API of something called Mapbox, and with that API, he's creating these apps. And while he's creating these apps, he's also sharing his code on YouTube. So there's a link over there. You can have a look at that. Then similarly, this he also does this for indoor mapping. So some kind, this is again very simple stuff. This is not very difficult to do. By just watching one of his tutorials, you should be able to do it if you have the software installed on your system. So again, indoor navigation is one thing. Now, learning from these things, whether it is this or any of the Mapbox tutorials and all. So Mapbox has also done a lot of things along with Unity developers and created tutorials. So there also, if you have the data, if you have access to the data, creating a application is not difficult. This has gone to the next slide. Actually, I wanted to show another slide. There is a delay in the my system and the slides on the call. So yeah, this is the one I wanted to show. Now, augmented reality and mapping. So this is where basically this organization called Mapbox has done a lot of work. They have a wonderful API, and I think around 2015 onwards, they are using this, and they use OpenStreetMap. So at least around 2015, 2016, they had openly declared they are using OpenStreetMap. Now maybe they have their own, location intelligence map or whatever is there. I can't really say. Uh, using OpenStreetMap, some of these things are possible. And again, using Unity, you can end up creating something like this. So what you see on the right side is not a map. It is it's a 3D this thing created using Unity 3D. But it is actually the exact this thing mock-up of a area where the longitude latitude is shown on the screen. So wherever that is, so you can end up creating. So this is not very difficult to do. But then again, how will you get the data? So data is the bigger challenge here. Now this is what lidar looks like. So lidar is the most advanced. So on top right, top left, you see that there is an image. On top of that image, similar to OpenCV or something, they've created bounding boxes on top of buildings and all that. So that is the easy part to do. Down below, I think they are showing. I'm not sure, but maybe could be a lidar, this thing, data, whatever. And on the right side, using both of these, they've created a 3D mock-up of that. So using lidar data and using image processing, most probably OpenCV or DLib or YOLO or something, maybe, I don't know. Using some of these image processing libraries, they've created what is visible on the right side. So these things, all of these things are possible if there is data available. Now this is what is the open source QGIS. So Python plus QGIS, and again I've given a link over there. So if you look at this, you will understand how easy it is to do this. It's not very difficult. So what is being done by the ArcGIS, which is the paid software, which is used by large organizations like Pitney Bowes and Esri and all. They mostly use ArcGIS. That can be done with this open source QGIS also, and it's got a wonderful Python API. So you can also end up creating your own. Um, and I've done some work in this, not much, but I've ended up creating my own little uh, PyQt application and other things. So this is quite user friendly. This is not very difficult to use. So maybe going forward, we will probably end up using QGIS along with some Python plugins that we will create for our own self, and then we will process the data. Okay, this I just wanted to show. So I've done some work in Unity. So this is 3D, and I've also done a lot of things in augmented reality using Unity only. So again, very simple C# code. It is not very difficult to code. So doing the map part is more difficult. Doing the AR part is not that difficult. Now here again, using very simple few lines of code on Google Map images. So that is just for testing. It is not for production work, or it is not for some commercial use, but just using OpenCV and very simple screenshots from Google Maps. This can be achieved. So this is just about 10-15 lines of code that I written, I think 2-3 years back. And this is the again a small demo that I have from 2-3 years back on YouTube using QGIS. So these things can be done. So this is not such a big deal to achieve. Now, these are the problems we need to solve. So, availability of public data. So, Google Maps is questionable, not possible anymore. OpenStreetMaps, yes, maybe. LiDAR or satellite, if somebody gives us that data for free, which is impossible. I don't think so that will happen. Then the other challenge is recency of images or map data. So, if you're using OpenStreetMap also, then how recent are the tiles or the images or whatever it is that we will get from OpenStreetMap, or the data which is there, and the quality of images and data. So then remote locations versus metropolitan locations and things like that. So maybe for cities, data is available easily with OpenStreetMap, but remote locations again could be a problem. So yeah. So this is the end of the session. Any questions you have? How can you help? This is the GitHub org which has been created. I'll be putting some data over, putting some code over there, and then we can start participating in case you want to participate in this open source project. So, any questions anybody has for me now? This is the end of the PPT. Ayush, any questions? Divakar, Banish, Rachit. Okay, perfect. I'll share this. I'll put this on YouTube. You can see it again. If you have any questions, you can post them over there. Thank you so much for joining in. Thanks a lot. Any questions you have, you can post it on my LinkedIn also, or whichever way. No problem. Thank you. Thanks a lot. Bye. Ayush, anything? Okay, bye bye.